Let me try unmuting myself. Hello, this is Beth Dixon, and I work in the math lab at Walter State Community College. And we are going over the Math 0030 review. Although the top of my page says Math 1030 review. I will look at that to verify that this is the right page, but I'm pretty sure it's the right page. It's just the wrong title on it. So this is the review for the Math 0030 course, and this is the second page. So this is the second part, and these are problems 7 through 9. And as we begin, we're going to look, and the second one starts out, or the second page starts out with some exponents in order of operations. So let's look at this first problem. The first problem says -5 squared, but notice you have to pay close attention as to whether there is a parentheses or not in this problem. In this case, I think my camera froze up there for just a minute, but it should be back. This actually means the squared goes with the 5, and because there is not parentheses, that squared does not affect the negative. So that is 1 negative and 2 5s. So that is 5 times 5 is 25, and then we'll make it the opposite, which is -25. So if I type that in the calculator, I'll turn my calculator on here. I'm going to move it right there so you can see it nice and clear. If I type that in the calculator, that would be -5 squared. That would give me, whoops, I didn't type the squared. -5, and then I'm going to type the squared button is what I meant to hit, and that would be -25. I could also hit -5 and then hit the raised button and then the squared. I can either hit enter or the over buttons or get down, and then hit -25. If the problem had been written differently, I would have gotten a different answer. If the problem is written with parentheses, that would then give me parentheses -5 raised to the second, and would give me a +25. The difference here is that says the whole number is squared, not just the 5. So that would be -5 times -5, and that negative times a negative is a positive and gives us a +25. So if without the parentheses, the answer is negative, and with the parentheses, the negative is included, and the answer is positive. The next problem is -4 to the 3rd power. You can't see it, but I had to put on my reading glasses to be able to see that, which that means -4 times -4 times -4. -4 times -4 is a +16 times -4 is a -64. Now, I can do that math in my head because I sit around and do that all day. That's what they pay me the big bucks for. But you don't get paid big bucks to take this course. So how are you going to do it? You're going to type in -4 raised to the 3rd power, raised to the 3rd power, and enter, and that gives you the -64. The next one squares the 1. 1 times 1 is 1, and it does not square the 4, so it's 1/4. 1 squared, then divide 4, enter, and since we would prefer a fraction. It starts as a fraction, so we tend to end as a fraction. So I'll change that to a fraction and get the 1/4. Notice in the next problem, everything's included, so that means I'm really saying 1/4 times 1/4. Here it's just 1 times 1/4, which is the 1/4. Here, the 1 and the 4 are both included, and that gives me 1 over 4 times 4 is 16. Parentheses 1 divided by 4. Then raise all of that to the second power. Don't forget to use your over button to move down out of the exponent. And then we want to make that into a fraction for an answer. And so that gives me the 1/16. 14 to the 0 power. Anything to the 0 power is 1. 1/2 to the 0 power is 1. 5x to the 0 power, well, is it 1? Well, 5 is raised to the first power. X to the 0 is to the 1 power because that 0 doesn't go over to the 5. So that is 5 times 1, which is 5. The same thing happens here. That negative is not included. So that's the opposite of 8 to the 0, which is the opposite of a 1, which would be -1. So let's check that on the calculator. And we do get the -1. So you have to remember that an exponent only goes with what it's right next to. And you can see the shadows of my hand as I'm talking with my hands here. But it only applies to what it's right next to. So when we have a negative there, that exponent here or here does not apply to the negatives that are there. It doesn't apply to the 4 that's down here. The exponents only apply to the number that's right in front of it. Then, as we look down here below, we're ready to do the order of operations. Depending on your teacher, you'll either use "Please excuse my dear Aunt Sally," or you'll use grouping, exponents, multiplication and division, addition and subtraction. They're both really the same. This way it helps you remember that multiplication and division are the same level and addition and subtraction are the same level. This one you have to remember that these two are the same level and these two are the same level, but it's a little easier to remember the saying because it's an old saying that we've used for years. So as we do this, we look and we have 5 plus 3 times 2. There are no parentheses in that statement. There are no exponents, but there is a multiplication. So the first step would be to multiply that 3 times 2 and get 6. Then I'll bring down the 5 plus. 5 plus 6 is 11. In the next problem, I do have an exponent. I do not have any parentheses, so I would do that exponent first. That gives me 25 minus 40 divided by 5. 25 minus 40 divided by 5. Then I would do the multiplication and division from left to right. That's a subtract. Then I come over here and do 40 divided by 5, or think of it as a -40 divided by 5. That subtract makes that 40 look like a duck, walk like a duck, so it's a duck. It looks like a negative, it acts like a negative, so we'll treat it as a negative. So we can kind of just cover that up and say, what is a -40 divided by a +5 would be a -8. Then bring that 25 down, and then we have 25 minus 8, and I don't do subtraction in my head. Some of you are really gifted at that. I'm going to use my calculator and get 17. So I've used my calculator to help me out in things that I don't know, but I have shown all my steps. Then I'm going to go back and I'm going to check this one, and I'm going to type in 5 raised to the second power. Remember, you're in an exponent, so I'm going to arrow over to type in the rest of the problem. Minus 40 divided by 5. Notice the division symbol doesn't look the same, but it'll be treated the same on your calculator. This works as long as you're using a scientific note calculator, but doesn't work if you're using a non-scientific calculator. In the next problem, again, there are no exponents and no parentheses, so we're ready to do the multiplication and division from left to right. The first multiplication we reach is that 12 times 4, and we can treat that as a negative 12 times 4. 12 times 4 is 48. Now, notice I didn't put the sign in because I know a negative times a positive is a negative. So that's 84 minus 48. Then I'm going to go on and do the next step, which would be to say that 160 divided by 16, because doing this step won't affect either of these numbers. And 160 divided by 16 should give me 10, not 13, but 16 should give me 10, and that would be a positive 10. And now I can do the addition and subtraction from left to right. And as I look at this, as looking at it from left to right, I would do my 84 minus 48 and get 36 plus 10, and that would be 46. 84 minus 12 times 4 plus 160 divided by 16, and double check that gives me 46. In the next problem, I finally have one with parentheses. And so what I want to do is use my fingers. I tell people math is a two-fingered, two-hand job. So what I'm going to do is go into the smallest parentheses, and I have 2 of those. So in this first one, I'm going to cover everything else up and look what's inside. Inside that parentheses, I do not have anything other than a subtraction. And so inside that one is 11 minus 5. That's an easy problem for me to do. I can do 11 minus 5 and get 6. I'm going to cover all that up, and I'm going to look inside this one, and I have an exponent. So I'm going to do the exponent first and get 6 minus 2 raised to the 3rd power, which is 8. And then since that's still in that parentheses, I'm going to do 6 minus 8, which would be negative 2. Notice I keep it inside that parentheses. Now I'm going to keep this inside the parentheses as well and bring down the parts that I haven't used. I haven't used the 24. I'll bring it down. I haven't used the 9. It's inside that bracket. Plus, inside the parentheses is 6. Then that subtract, and then it's in here. So the next size, I've done the smaller parentheses. This is the next size. So I don't want to do any subtract or anything out here, any kind of multiplication. I just want to look inside that next size parentheses. Notice I cover up everything outside. That's what my fingers are for. So inside I have 9 plus 6 minus a negative 2. Well, I can write that as 9 plus 6, and I want to use a different color here and make that subtract, adding the opposite. So that becomes 9 plus 6 plus 2. 9 plus 6 plus 2 should be 15 plus 2, which is 17. And that 24 minus should be on the outside. So that gives me 24 minus 17, which should be 7. So 7 is my final answer. So let's look at that and type it in. And when you type it in on the calculator, remember that your calculator doesn't care what size the parentheses or brackets are. It's smart enough to know open and close, and that's what it uses. So I just open one, then 9 plus, open another, 11, subtract 5, close, minus, open, 6, minus 2 raised to the 3rd. Remember when you're in the exponent to arrow over. then close that parentheses, close the bracket, and press enter. And that gives me the 7 to tell me that I'm correct. Let's go on to the next problem. Again, I will go to the smallest set of parentheses, cover up everything else, and only concentrate on the inside part. 9 minus 2 would be 7. I'm going to copy down everything else just like it's written. Then I'm going to look at what I have left. That would be the next set of brackets. Again, copying and covering up everything else. Inside, I have an exponent, a multiplication, and an addition. So I do the exponent first, 3 squared. So that would be 9 plus 7 times 4. And then once I do that, that would be 9 plus 28. 9 plus 28 gives me 37. So what does that leave me? 4 times 37 minus 10 times 3. Well, I'm kind of running out of room here, which is why I have the whiteboard. So I'm just going to flip this around, reach over here. Whoops, nope, there it is. Knew I had a pen somewhere. So now I have 4 times 37 minus 10 times 3. I just copied the same problem so that we wouldn't lose our place. 4 times 37 gives us 148 minus, and then I can go on and do that multiplication there, which would be 30. And 148 minus 30 should give us 118. So that's the answer I come up with, is 118. And in this case, because it's a lot of work, I definitely want to check this one. Again, I've shown my work. I can use my calculator to do the computations, but I've shown all my work. So that's 4 times, open a parentheses, 3 squared. Notice this time I use the squared button. Sometimes I use the squared, sometimes I use the raised. That's what I call the raised. Whoops, you're not seeing that. My apologies. Let me do that again. 4 times parentheses 3. Sometimes I use the raised button, sometimes I use the squared button. Just depends. That's 4 times 3 squared plus 9, whoops, and that's another open parentheses. 9 subtract 2, close the parentheses, times 4, close a parentheses, minus 10 times 3, and I hope that's 118, which it is, so that means I got it right. And we'll slide this back underneath and we'll pick up where we left off and do the next problem. 2 to the 4th times 5 minus 20 divided by 2. So we do what's inside the parentheses first. 20 divided by 2 is 10. So that's 2 to the 4th times 5 minus 10. I can do 2 to the 4th in my head because that's one of those number tricks I sit around all day playing with, but just you probably can't. Don't worry about it. That's what your calculator's for. 16 times 5 minus 10. 16 times 5 would give us 80. 80 minus 10 equals 70. Now, the next 3 problems involve variables. As soon as we involve variables, the calculator becomes second. We will not use our calculator unless it's to work with the number parts of these problems. The algebra has to be done in our head because our calculator that we're allowed to use in this class does not allow us to do so. Okay, now when it's squared, I'm going to divide this problem into, instead of doing one problem, I'm going to divide it into 3 simpler problems. In other words, if that's squared, that means not only when we have 5x squared y to the third squared, that really means we have 5 squared x squared y to the third squared. 5 squared means we have 5 times 5. So that gives us 25. And I said x squared squared, but I don't think I wrote x squared squared. But that's x squared, and then it gets squared. And so what we're saying here is that we have 2 sets of 2. And when we have a base raised to a power a power on a power, the rule there is that we multiply the exponents. That is x to the 4th. If you want to think about it, that's really x squared times x squared. And when the bases are the same, we add our exponents. But we're saying we have 2 sets of 2. With the y's, that means we have 2 sets of 3. So we are multiplying 2 times 3, or adding 3 to itself, which is why we multiply. So 3 times 2 is 6. So we have 2 sets of 3, which is a multiplication. So the answer should be 25 x to the 4th, y to the 6th. In the next problem, we're doing the same thing, but it's a quotient, a division problem. So we simply have 3 to the 3rd, x to the 4th to the 3rd, 2 to the 3rd, and y to the 3rd. We can use our calculator to help us out, but 3 to the 3rd would be 27. 3 sets of 4 would give us 12. 2 to the 3rd, notice that's not going to be 2 sets of 3, that's 2 times 2 times 2. 2 times 2 times 2, or 2 raised to the 3rd, which would be 8. And then 3 sets of 1, which would be 3. So our answer would be 27 x to the 12th, 8 y to the 3rd. In the next problem, we're going to simplify and divide, but again, I divide it into smaller bites. It's what I call my elephant theory. In my elephant theory, what I look at is taking a big, ugly problem and dividing it into smaller bites. How do you eat an elephant? The old joke goes, 1 bite at a time. So I take this problem and just rewrite it thinking about the numbers, thinking about the x's, and then thinking about the y's. Well, if I take 24 over 16, I can think about that with my calculator. I can take negative 24, divide 16, and reduce that fraction with the calculator. I can also remember that 24 and 16 are both divisible by 8. 8 goes into 24 3 times, 8 goes into 16 2 times, and I have a negative. Then I can look at my x's. With my x's in division, remember you'll subtract. In division, you subtract the exponents. 3 of these x's will divide out and take away 3 of the exponents, leaving 5. And 2 of the y's will divide out, leaving 5 y's as well. So you go 8 minus 3 to get 5, 7 minus 2 to get 5. So that's negative 3x to the 5th, y to the 5th over 2. Okay, let's look at the next part, which is to simplify each expression. Okay, as I look at the simplify each expression, I want to add like terms. 6 plus 4x minus a negative 3x. I want to rewrite that, simplifying my signs there to adding a positive 3x, and I left off the x there. Then these are my like terms. The 6 does not have a like term. 4x plus 3x gives me 7x. When I look up here, I have like terms of negative 4y and 3y. Whoops, and a 7 and 11. Let's do the 7 and the 11 first. They're both positive, so 7 plus 11 is 18. Negative 4 plus 3, they're both y, so negative 4y plus 3y would be minus 1y. And you can write the 1 or not. And then 8x minus 7x would be plus 1x. And again, I could write the 1's there and the 1 there, but I will leave those off. In the next problem, there's my 12x, there's my 4x. So those are like terms. So 12x minus 3y plus 4x minus 2y plus 5, my first like terms would be the 12x and the 4x. They're both positive, so that would give me 16x. Then I've got a 3y and a negative 2y. They're both negative, so that would give me minus 5y. And then the plus 5 has no like terms, so it comes down as is. Okay, let's look at the next one. Negative 2y to the third plus 8 minus 4y squared plus 5y plus 3y squared minus 12. Well, there are no like terms to the 2y to the third. And I'm going to do the y squareds next so that I can just count down the powers of my y's. In this case, a negative 4y squared and a plus 3y squared would give me a minus 1y squared. And this time I'll write the 1. You can write it where like I did here or leave it off like I did there. Next, I'm going to look for my y's. And you can kind of check off what you did. So my y's would be here. And there's not another y, so that'd be plus 5y. And then my plus 8 and my minus 12 would mean their signs are different. So I'm going to subtract and keep the sign of the larger number. So that would be a negative 4. Next, 4x to the third minus 4x plus 5x squared plus 2x minus 3x to the third. Starting with the highest power would be the 4x to the third minus 3x squared would be x to the third. Plus 5x squared plus 2x squared gives me plus 7x squared. And that only leaves the minus 4x. The last one, again, adding like terms. We want 5x squared minus 3x plus 2y squared minus 4x squared. I'm going to start with the x squareds. So that gives me 5x squared minus 4x squared, which does not give me 5. That gives me 1x squared minus 3x plus 2y squared minus 3y, because those are the only like terms. Remember that to add, they have to be identical variable parts. And I'm pushing the limit on the time here, so I will do problem 9 in the next video. Thank you for watching. If you need help, you can contact me at beth.dixon@ws.edu.